Let's start with malaria, which affects more than 200 million people per year with tens of thousands of deaths. You'd think it's very simple to get rid of mosquitoes or use a mosquito net and deal with malaria, but that's not obviously the case, especially in poorer countries like Africa or developing countries like India and other tropical countries. We looked at this before, so let's look at this again. Direct climate change effects on disease vectors, just to emphasize some of the points I made earlier. The change environmental variables that change, of course, include temperature, winds, precipitation, and relative humidity, which affect the species, everybody including us. So temperature affects changes in distribution boundaries, high latitudes and altitudes, effects on biology and physiology of humans as well as pathogens and their hosts, acceleration of pathogen development. So the life cycle can change in such a way that the incubation period of certain pathogen, once it enters the bloodstream of the host or the person who's infected like us, which is what we are worried about, can change, which can change the disease outcome as well. Completion of cycle at higher latitudes and altitudes is always an issue. We mentioned Africa before and highlands where mosquito lines can go up and diseases can take hold. Wind patterns change migration of certain vectors. Birds which carry West Nile, for example, the pathogen can hitch a ride to very long distances based on their migration patterns, which can be affected by wind patterns. Precipitation patterns, of course, affect the changes in length of seasons that vectors can survive, plus droughts and floods, as we saw specifically, can also affect the interactions between humans and rodents, humans and birds, humans and pathogens, and so on. For example, during a drought, when water bodies shrink, more birds can congregate to the remaining water bodies and get exposed to certain pathogens, and then humans can become susceptible because the mosquitoes can bite the birds and bite humans and spread the diseases. This also happens in places where people use rivers for washing clothes and so on, or bathing, and during the droughts they can get shrunk and contacts can go up. So complicated interactions can happen. Changes in relative humidity can affect vector lifespan, effect on genetic composition of the vector population. So these are kind of broad concepts, but it gives you a sense of how complicated it is to track end-to-end from weather to disease outcome. Indirect climate change effects on disease vectors include desertification and drought, other changes in vegetation, hydrologic changes. We had a podcast on this in the last chapter, changed agricultural practices, and changes in irrigation practices, cropping patterns, pesticide application, and livestock. So we looked at briefly at the impacts of water and food security and nutrition and so on as well, right? So just in terms of details, desertification and droughts can affect reduction in density of water-related vectors. When drinking water sources become scarce, more chance of guinea worm transmission. Very specific example there. Changes in distribution of rodent reservoirs, sandfly, and other affecting black fever. And changes in vegetation can lead to effects on tsetse fly distribution and risk factors. Of course, that's a vector here. Affects tick distribution, bacterial and viral tick-borne diseases. So we're going to talk about some of those, like Lyme, for example. Hydrological changes, we looked at quite a few details, but formation of more brackish water lagunae, extending breeding or brackish water species, extending the breeding or brackish water species, changes in riverbeds affecting tsetse fly ecology, so not just their abundance but their ecology, their habitat and interaction with the surroundings and environment. A wide range of the agriculture and these other practice changes will lead to a wide range of effects on mosquito-borne and snail-borne diseases. Okay, this is very critical as well. To go into malaria, look at first the various mosquito-borne diseases here and their distribution. So there is malaria, dengue. We will look at these two in a little bit more detail. Tick-borne encephalitis, which is stuck to this latitude band here, which means the subtropical, tropical, or mid-latitude subtropical front here, which is quite sensitive to climate change, temperature change, equator to pole temperature gradient, and so on. So here you have European, Far Eastern, and Far Eastern countries going all the way into Japan. Lyme neuroborreliosis, we will look at this a little bit more, but you can see that there is a growth of Lyme here more recently, but there are the regions where it is seen. That's a tick-borne disease. The vector or the host varies. Here it's deer, but there are other hosts as well, as we will see. Yellow fever, mosquito-borne chikungunya, now has taken hold over a broad range of the globe, starting as obviously a very much a tropical disease, going from Madagascar to China, India, Europe, and everywhere else now. African trypanosomiasis, Chagas disease, visceral leishmaniasis, West Nile. Oops, sorry, I don't know why my computer does that. Apologies. West Nile virus. So we'll look a little bit more at West Nile virus. I lost my cursor here. There it is. Somebody suggested I use a laser, but somehow I'm allergic to laser. Okay, but I hope you can see the cursor moving anyways. Okay, so 5 species of the malaria parasite infect humans. Falciparum, so Plasmodium falciparum, Plasmodium malariae, Plasmodium vivax, ovale, and knowlesi. Okay, so those are the parasites, and we will look at specifically 4 countries where there has been a so-called re-emergence of malaria. So you can see the trends here. Venezuela, these are going from 2010 to 2017. Clearly there is a huge increase in the estimated cases, going from 100,000 to more than 500,000. Brazil had a drop, and then it seems a little bit of an uptick here. Nicaragua has had a bump up, and Peru is showing some increase and then maybe a decrease or a flattening. So you can see from Venezuela it's spreading in every direction, including to the US, and estimated malaria deaths over this period are in these numbers here. Are these climate driven? That's the key question always. Clearly there is a human demographic movement involved, but the key of course is also how the mosquito population abundance, its life cycle itself changes, and how its pathogen that it's carrying changes, in addition to how human beings are moving, but how human movement itself is affected by climate. Okay, so you can see that the story gets quite complicated, and it's not always easy to relate. Even, for example, if you find a correlation between, let's say, El Nino and some disease outcome like this, El Nino affects, it produces a drought on this side, whereas floods and landslides and so on this side, and has a mixed effect here through hurricanes changing. So El Nino reduces the number of landfalling hurricanes, whereas La Nina would increase. So obviously this is not so hurricane prone, but here you do get precipitation affected by cyclones and hurricanes. And you get changes in wind patterns and temperatures, precipitation, and so on. So pretty much everything changes, not just the trends, but the variability. We don't know how climate change is affecting El Nino, for example. It's possible that instead of warming near the west coast of South America, now El Nino is warming more near the dateline. So these kinds of details matter. So we will leave that there and give you a sense of malaria being very much present and still a huge impact in terms of number of people getting affected and number of deaths overall, especially Africa. And we had talked about DDT, which was used as an insecticide before in the 1960s, and after the Silent Spring book by Rachel Carson, it was banned, and eventually it's now being thought that maybe bringing back DDT as a limited mosquito killer can help. But other measures like using nets or malaria vaccines and reducing exposure and so on will matter. For example, even if mosquito population increases, the exposure by humans in rich countries will be reduced, but just because they are they got mosquito repellents, they got ACs at home, they are taking care of mosquitoes in urban settings, and so on and so forth. So it's all these factors together that will determine the malaria outcome in the coming years and decades. But this gives you a sense of what One Health or planetary health means. When you want to worry about just malaria, you have to worry about not just weather and climate, but mosquito life cycles, the Plasmodium life cycles, human migrations and impacts, environmental factors, ecology, social, political factors, and socioeconomic factors. Okay.